Good morning, children. Good morning. Good morning, Kirti. In our last lecture, we studied different applications of CRO. Okay, is it clear? Is our board is visible to all of you? Are you able to listen me and please comment? We will wait for some time. Good morning, Kalpesh. Good morning, Mrunmai. Good morning, Kirti. Hello, all of you. In our last lecture, we yesterday we study about applications of CRO. We studied two applications of CRO, how we able to measure that AC voltage and DC voltage by CRO, by using CRO, cathode ray oscilloscope. Okay. Now the third application, that is time period measurement. Do we study that DC measurement? Yes. Yes or no? AC and DC both. Yes. I draw here diagram for that DC also. Okay. First we study about first application is AC voltage measurement. Second, okay. Now third, today we study about time. Write down the heading as time period measurement. Time period measurement. Okay. For that, again we have to Now is it visible? Okay. Time period measurement. Okay, time period measurement. Is it visible now? Okay. Now, time period measurement. In our last lecture, as we draw that diagram of screen of CRO. On screen of CRO, suppose there is a sine wave with positive half cycle and negative half cycle. To adjust that exactly once, at least one cycle of that sine wave, we have to adjust volt per division knob. By moving that volt per division knob, we try to adjust at least one single cycle of that sine wave on a screen of CRT by varying that volt per division knob. Like that, again by varying that volt per division knob, we adjust for DC voltage also. For DC voltage, we just see a straight line, and for AC voltage, we see sine wave, positive half cycle and negative half cycle of sine wave. Now, third application is time period measurement. Now, we try to measure the periodic time of that sine wave which is on a screen of CRT. Okay. So, for that, how many of you are there? For that, we draw again the diagram. Diagram of screen of CRT. That graph or like this. Means the diagram or screen of CRO is like this, and here vertical lines are also there. Vertical lines, suppose you draw, suppose all that are equidistance. Imagine all these lines are equidistance. So by adjusting time per division knob, we will try to adjust at least one cycle of that sine wave with its amplitude. Okay, proper full amplitude. So here suppose 1, 2, 3, 4 at 4. And here also 1, 2, 3, 4. 4 means this one, this line. And here we select suppose 4 for half cycle and remaining 4 for this one. Suppose this is our positive half cycle and this is our negative half cycle. In this way we draw the diagram. Okay. Now for time period measurement, time is equal to the formula for time period. Time period is equal to number of vertical divisions. Number of horizontal divisions. Number of horizontal divisions multiply time per division scale. multiply time per division scale. Time period is equal to number of, is it visible for everyone? Say yes or no. Please give reply. Are you okay with this font size? Okay. Good morning, Kalpesh, Prasad, Kirti. Okay. Time period is equal to number of horizontal divisions multiply time per division scale. Suppose for this, to get the sine wave like this, we adjust time per division knob, and that time per means like for that time per division means when we vary time per division knob, this wave moves like this. And when another direction, this wave compresses, expands, compresses by using that time per division knob. ओके कॅम्पसला लिंक गेली का? ठीक आहे. ऑलरेडी आय सेंड लिंक टू बोथ. ओके. Yes. So by varying that time per division knob, we adjust the wave on a screen of CRO like this. Therefore, the formula for periodic time is number of horizontal divisions into time per division scale. So both to adjust that, this similar wave on a screen of CRT. Suppose time per division scale is suppose 10 millisecond per division. For example, 10 milliseconds per division means one division. To complete the one division, that wave require 10 milliseconds like that. Or 10 is much more. Suppose we consider 2 milliseconds. For example, 2 milliseconds. So for periodic, to calculate the periodic time means time required to complete one cycle for our sine wave, that is nothing but our periodic time. And time period is equal to number of horizontal divisions. Now count that horizontal divisions. 1, 2, 3, 4, 5, 6, 7, 8. Number of horizontal divisions are 8. And what is the time per division scale now for present situation, for present example? Time per division now we keep on 2 milliseconds per division. So here 2 milliseconds per division. Therefore 16 millisecond. Here also division, here division cancel, millisecond. What is the time? T is equal to, for the similar wave, periodic time T is equal to 16 milliseconds. Do you understand? Means in this way, suppose the exam question is like that, explain time period measurement by using CRO. At that time you consider any example, not necessary draw the sine wave like this only. You may consider the sine wave like this. Suppose for this sine wave, the periodic time is 1 millisecond per division. So how many horizontal divisions for this complete cycle? This one is the complete cycle, positive half cycle and negative half cycle. So how many horizontal divisions are there? 4 horizontal divisions. Therefore T is equal to 4 multiply. At that time, what is the time per division scale? 1 millisecond per division. Therefore you have to write here 1 millisecond per division. Therefore your answer is periodic time is equal to 4 millisecond. And for this, the periodic time is 16 millisecond. Any example you may consider. Okay? For explanation of this third application, that is the time period measurement. Everyone understand this? Okay? Now we go to the next application, that is the fourth, frequency measurement. Now there are two types of frequency measurement. You may measure the frequency similarly like this. Find out the periodic time and then you know f is equal to 1 upon t. Time per division scale दिलेले असते का? नाही. We have to consider. Rudmai? We have to consider any digit you can take. But you consider that too. For one wave it requires very little time. So you have to consider in millisecond. You may take it as 2, 10. When we perform the practical, at that time we actually adjust that time per division knob. So there are different divisions, 2, 4, 6, 8, 10, like that, milliseconds. At that time you able to observe what is the time per division reading. But here you have to consider that for adjustment of such a wave or the given you don't know the what is the input wave speed, according to that periodic time changes. Okay. Then shall I send link again, Brunmai? Okay. 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 Now, हे समजलं सगळ्यांना. Next one, for frequency measurement, you simple first method of frequency measurement. Maximum time the question on frequency measurement. How frequency is measured by using CRO. That one is the 3 or 4 mark question. At that time, sometimes they ask about 2 methods. Give 2 methods of frequency measurement. At that time, you have to explain both the methods of frequency measurement. Or if they ask plain question that how frequencies of the input signal is measured by using CRO, at that time you may explain this simple method. That draw the diagram like this. Suppose our first diagram we consider only this one. We consider our first diagram like this. This is our wave. We want to calculate the frequency of the same wave. So go like this, time period measurement. First calculate the periodic time and then after that for calculate the frequency. You know the formula for frequency, that T is equal to 1 upon F, right? T is equal to 16 millisecond. Therefore, F, you know that F is equal to 1 upon T is equal to 1 upon 16. Remember to calculate this. You have to go with that millisecond. So don't forget to write that millisecond. Means 10 raised to minus 3. So 1 upon 16 into 10 raised to minus 3. Calculate this 0.06 into 10 raised to 3. So something is there. 4. 62. Therefore, 62 hertz. 62 hertz is the frequency, or you may write 0.062 kilohertz. So remember this milliseconds 10 raised to minus 3. Whenever it is in numerator, it becomes 10 raised to plus 3 and F is equal to 62 hertz. Okay? In this way you can. This is the first method for frequency measurements. So here we have to write first fourth one. Frequency measurement by CRO. Write down the heading as frequency measurement by CRO. At that time, Similar steps you have to calculate like previous time period measurement, and then after calculating t, just make reciprocal of that t and find out the frequency. Now what about the second method to find out the frequency? When see in your textbook, second method using Lisa just figure. See that diagrams. What is the meaning of Lisa just figure? That is given figures given in your textbook. For that, what do you have to do? Listen carefully now. To that CRO, we have to provide one known frequency signal. One known frequency signal to the horizontal amplifier, and the signal of which we try to calculate the frequency to that vertical input. And when you gave both the signals to that CRO, vertical input signal and horizontal input signal, suppose you get ellipse on our CRO screen, then what is our conclusion? That the unknown frequency signal is of same frequency. Unknown frequency signal is same as the frequency of known signal. Suppose the input signal, known input signal. Known means known frequency. F known is equal to suppose 1 kilohertz. We previously know the input signal's frequency, that is 1 kilohertz. We apply to the horizontal input and to that vertical amplifier. Horizontal means horizontal amplifier, and here external input is given. So that vertical input we apply F unknown. And to that horizontal amplifier we apply F known. Do you understand now? Means two signals are applied. Means we want to calculate the frequency of that unknown input signal. Means we don't know the frequency of this signal, and here F known means here known input signal is applied. Okay. So if whenever both the signals are applied, if on a screen of CRO we see circle, at that time both having same frequency. Means suppose the frequency is 1 kilohertz, so this unknown frequency of this input signal is also 1 kilohertz. Suppose we see ellipse, you understand ellipse, like this, means ellipse okay. Then at that time also the frequency of both the signals is same, only difference is that there is a phase difference between the both signals. Do you remember in our 11th we studied in detail about phase lagging and phase leading. Phase lagging and phase leading means suppose these two waves of different amplitude, they are in same phase. Suppose like this. This is the first signal, this is the second signal. They are out of phase by 180 degree. Suppose here first wave is like this and second wave start like this. Then how much phase lagging? This wave, second wave lags by 90 degree, because here you are 90, here you are 180, here you are 270 and here you are 360 degree. Okay. Means that is, you better understand phase difference. Do you remember? All of you? आठवते आपण 11th ला शिकलोय. So when you see ellipse on a screen of CRO, there is frequency of both the signals is same, but there is a phase difference between two waves. Okay. Now, other than that, you may see whenever there is different frequencies, means known frequency signal is 1 kilohertz and our unknown signal having the frequency differ than 1 kilohertz. At that time we see the figures on a screen of CRO. That figures are known as the Lissajous figure. I try to draw that Lissajous figure. Lissajous figure. Suppose the figures oval shape figures are like this. Either like this or like this. These are known as Lissajous figure. Any number of like this. Okay. Maybe. Now for that the formula, how you calculate? If you on your CRO screen the figure like this, at that time how you calculate F unknown? Suppose for this figure A, try to calculate unknown frequency, therefore F unknown is equal to the axis, how many vertical lines are cut and horizontal. The exact wording. Number of loops cut by horizontal line and number of loops upon number of loops cut by vertical line and multiply F standard. The standard input signal we applied already to horizontal amplifier or to horizontal deflecting plates, or horizontal input is provided with known frequency. That frequency is multiplied there and number of loops cut by horizontal line. Now listen carefully. Number of loops cut by horizontal line. Here your x-axis and here your y-axis. Number of loops cut by horizontal line. How many loops? Only one loop. And number of loops cut by vertical line. 1, 2, 3, 4, 5. So 1 upon 5 multiply F standard or F known. Therefore, the unknown frequency is given by F standard upon 4. Right? For this figure, you may consider what explaining the frequency by Lissajous figure. You may consider any diagram, any number of loops, maybe more than 5, maybe less than 5. Okay, but for such a diagram, the calculations are like this. Suppose another diagram, suppose B. Do you write all these things? Do you want to write all this? Yes or no? Because I think in textbook different examples are given and we consider different example here. So both the Lissajous figure nature is like this. At that time, this formula, again similar formula, f unknown is equal to number of loops cut by horizontal line upon number of loops cut by vertical line. Multiply f standard. Now what is the situation, present situation for this diagram or for this Lissajous figure? Number of loops cut by horizontal line. How many loops cut by horizontal line? 1, 2, 3, 4, 5, 6. So here you have to write 6 now. And number of loops cut by vertical line only 1. Therefore, our answer is 6 multiply f standard. And this one is the known frequency. Multiply by that known frequency by 6. Then you get that unknown frequency of your input AC signal. Means in this way you are able to calculate the frequency of any input AC signal by using CRO. So there are two methods. One simple method is by measuring periodic time and then make the reciprocal of that periodic time. You get the frequency. Second method is by Lissajous figure. Okay. In this way everyone understand this. Prasad, Kirti, Mrunmay, are you there? Kalpesh. Okay. Do you understand? Please reply. Okay, Mrunmay. Okay, Kirti. Okay. Prasad. No, ma'am. Prasad. Okay, again I repeat. Sankalp, very good. Ekda repeat kara. Okay, okay. Prasad say, so listen carefully. First one is quite simple, that calculate T and then make reciprocal of D. In this way you easily calculate. Now go to this diagram. Go to this diagram. Okay. Here you apply the signal to which you try to apply this unknown frequency signal to vertical attenuator, and here to that external input is given. To that horizontal amplifier you apply the known input frequency signal, means known frequency signal. ज्याची फ्रिक्वेन्सी माहिती आहे असा सिग्नल कुठे अप्लाय करणार आहे? या हॉरिझॉन्टल एम्प्लिफायरला. आणि ज्याची फ्रिक्वेन्सी कॅल्क्युलेट करायची आहे तो कुठे अप्लाय करणार आहे? वर्टिकल इनपुटला. ओके. सो हाऊ बोथ द सिग्नल्स आर अप्लाइड. दोनही सिग्नल अप्लाय केल्यावर काय पॉसिबिलिटीज असणार आहे? जर सर्कल आलं स्क्रीनवर तर काय मीनिंग, त्याचं कन्क्ल्युजन काय असणार आहे की दोनही सिग्नलची फ्रिक्वेन्सी सारखीच आहे. हॉरिझॉन्टलला जो सिग्नल अप्लाय केला आहे त्याची फ्रिक्वेन्सी आणि ज्याची आपल्याला काढायची आहे त्याची फ्रिक्वेन्सी सारखी आहे. हे कन्क्ल्युजन केव्हा असेल की जर आपल्याला सर्कल दिसला. सपोज वी सॉ ellipse on a screen of CRO, then also the frequency of both the signal remains same. Only there is a phase difference, and just I told you what is the phase difference. That how much phase difference is there that we cannot get by using this method, but just we conclude that there is a phase difference between the two signals. Okay. Now either ellipse or circle, or third and fourth options are like this. Suppose we see the pattern like this or the vertical loops like this. They are known as a Lissajous figure. And for that Lissajous figure there is a formula to calculate that unknown frequency. What is the vertical signal provided? We want to calculate the frequency of that vertical signal. So that unknown frequency is given by number of loops cut by horizontal line. Do you understand? Vertical loops horizontal loops. You understand horizontal line. How many loops cut by that horizontal line? 1, 2, 3, 4, 5, 6. From figure it is clear that total 6 loops cut by that horizontal line. That's why at the numerator I write here 6. And what is the denominator of our formula? Number of loops cut by vertical line. So how many loops cut by vertical line? One single loop. So I write at denominator 1 and multiply by F standard. What do you understand by F standard? Means second input signal we provided to that vertical amplifier, that is known as a F known also, and we have to multiply this ratio by 1. Okay. So 6 multiply F standard. Suppose F standard is 1 kilohertz. At that time, the unknown frequency is of 6 kilohertz. Okay, Prasad, do you understand now? Samajla? Okay, Prasad. Very good. All of you. Sankalp is also there. Now today Sanika and Kanak absent. Sanika, Kanak and Anvi also absent. Now these are the 4 applications of CRO. AC voltage measurement, second one DC voltage measurement, third one time period measurement, fourth one frequency measurement. In 2 ways we are able to calculate the frequency by using CRO. Now next one is the phase measurement. Write down the heading as, at least you have to write down the headings and write some formulas also in your classwork notebook. Then you remember what we studied previous. Phase measurement. For that we have to draw one block diagram for phase measurement. See that block diagram in your textbook, that there are 3 blocks. First one is the known vertical signal. Center laga asnare vertical signal is provided to that audio signal generator and circuit being tested and CRO. These are the 3 blocks. Audio signal generator here, the block of audio signal generator. The signal is provided from that audio signal generator to CRO, cathode ray oscilloscope. In short, we write here CRO and here circuit to be tested, of which we want to measure. We generate some waves, that is circuit for testing. AD circuit we connect here. The signal from that audio signal generator goes to that circuit also and to the CRO also. And after passing the same signal through that circuit for testing, that goes to here, means CRO receives 2 waves, one from the circuit and one simply from audio signal, simply from the audio signal generator. Means 2 signals provided to CRO, of which they are going to check the phase, whether they are in phase, out of phase, by 180 or 0 or 360 or maybe 270. All these things you understand. 0 phase difference, 0 degree phase difference. Listen here. Suppose these two waves are like this, then what we say, phase difference is equal to 0 degree. Do you understand? Okay. Second one, suppose phase difference is 80 degree. Sorry, not 80, 90 degree. Means first wave is like this at 90 degree, another wave of any amplitude. You may vary the amplitude or you may keep amplitude same also. Here the 90 degree. What about 180? You easily understand 180. Suppose the first wave is like this and second wave is like this. Then what is the phase difference? 180 degree. And what about 270? Now here first wave complete 90, and when it completes 90, then another wave will start. Means second wave starts after when first wave complete 270 degree, then another wave start, that is known as a 270 degree. Phase difference is 270 degree. Okay. So these are the different. So when we connect the circuit of which we want, means we generate some different audio signal of different phase waves, and here the same means some audio signal is provided to CRO. We want to check that the phase difference between these two waves. Suppose we want to keep the similar phase. Okay, similar phase. At that time we have to adjust here on CRO something to make same phase, but before that we must know what is the phase of these two waves. Suppose we see the pattern on a screen like this, on a screen of CRO. At that time phase difference is 0 degree or 360 degree. Okay, if we get circle on a screen of CRO, at that time phase difference is 90 degree or 270 degree. Is it okay? Just I check. Yes, right. Either 90 degree or 270 degree. And if we get the pattern on the screen of CRO is like this, at that time phase difference may be 270 degree. Means on a screen, when you apply to that CRO the two signals like this, first signal directly from audio signal generator and same signal through that testing circuit to the CRO. Now CRO has to judge the phase between these two signals. For that CRO, when CRO get these both the inputs, at that time if CRO shows the pattern like this, at that time phase difference between that two signals is 0 or 360 degree. If on a screen of CRO the pattern is like circle, at that time the phase difference is 90 or 270 degree. If we see the pattern on CRO like this, then the phase difference is sorry, 180. Okay. Now if the phase difference is other than this means odd number maybe 30, 35, 50 like that. Okay. For that you see the pattern of ellipse on a screen of CRT. The pattern like this. Ellipse. For that this distance, inner distance is termed as A, and outer distance. Outer distance means outer border of that ellipse is B. Therefore, at that time, ellipse is on a screen of CRT. On a screen of CRT, you may measure the distance A and distance B, and the phase difference. The formula for phase difference is sin theta is equal to A upon B. Therefore, theta is equal to sin inverse A upon B. In this way, you are able to calculate the phase difference between two waves. Okay? All of you understand this. These five applications, not four, sorry. 5 applications we have to study in detail, and maximum times, maximum not every time, there is one 4 or 3 mark question, at least one. And many times there are 2 questions on a similar topic. Out of these 5, you have to explain any 2, or on one numerical on this and one theory question. Maximum time the pattern is like that, one numerical and one out of these 5 you have to explain one. General question is like that, explain any one application of CRO. At that time there is a freedom for you, that you may explain AC voltage measurement, DC voltage measurement, time period measurement, frequency measurement, or phase measurement. With one you are comfortable, then any you are able to explain. If the question is general question is like that, explain any one application of CRO. But if the question is like that, explain AC voltage measurement by CRO, or explain frequency measurement by CRO, explain phase measurement by CRO, then the typical applications you have to explain. This one is one theory question, and maximum time one numerical on this. Now we try to simplify numerical. Now 8 students are joined here. Now all of you are having textbooks, because then it is quite simple for me to discuss the numericals, or I have to write down it. In next PDF pages, I try to send that exercise numericals also. Today only or tomorrow. Okay. I'm third box साठी 180 आहे. Okay. Sankalp don't have. Okay, Sankalp, I am going to send PDF. Now before that, just concentrate and read. Listen. Just concentrate and listen. I am going to discuss that solved examples, and then we simplify here that exercise numericals. Carefully write down all the solutions of exercise numericals. Just within 5 minutes. Just I discuss about solved numericals, and then we simplify here that exercise numerical. See that first page number 20. Those who are having textbooks and those who are not having textbooks, listen carefully and try to understand the numerical. Quite simple. Very simple. First one, page number 20. Solved one, that the deflection sensitivity of CRT is 0.03 millimeter per volt. Deflection sensitivity. Deflection sensitivity. What is the formula for deflection sensitivity? That the displacement upon applied voltage. Displacement on a fluorescent screen. That spot moves either in upward direction or in downward direction. What is the total moment of that electron beam? That is termed as a displacement. So that displacement upon applied voltage, that is the formula for deflection sensitivity. And deflection sensitivity in our example is given, that is 0.03 millimeter per volt. Deflection sensitivity is 0.03 millimeter per volt. Okay, and now what they say, an unknown voltage is applied. Unknown voltage. You have to calculate that unknown voltage. Applied voltage or applied voltage. Applied voltage is equal to what? Applied voltage you try to calculate. And what is another given data? That X plate, voltage applied to X plate causes the deflection of spot 3 millimeter. Means that displacement is given, means spot shift or displacement. Displacement is equal to 3 millimeter. So simple straightforward formula for deflection sensitivity. Just in previous 2 lectures we study about the deflection sensitivity. Deflection sensitivity of electrostatic deflecting plates is given by the displacement of a electron beam on a fluorescent screen to the applied voltage. Out means 3 data in a formula. Out of that 2 are given. You easily calculate the applied voltage. Therefore, what is the formula for applied voltage? Displacement upon deflection sensitivity. So, applied voltage is equal to displacement is 3 millimeter, okay? And deflection sensitivity is given 0.03. As both the given quantities are in similar unit, there is no necessity to convert in SI unit. So directly this is also in millimeter, this is also in millimeter. So easily you calculate that applied voltage, and applied voltage here is 100 volt. Okay. Now similar numerical, you try to simplify. Exercise first one in our, I think we try to complete in this lecture only, but before that we discuss the second numerical, that is the spot. Read carefully now. Those who are having textbooks, read carefully that the spot in CRO is shifted upward by 4 cm when 10 volt DC is applied. Second, solved second. Okay, when 10 volt DC is applied, at that time the vertical shift is 4 cm only. Now what they ask, find maximum displacement of spot when 7 volt AC is applied. Okay, 7 volt AC, 7 volt AC, 7 volt AC is applied. What is the maximum displacement of electron beam? Okay. 7 volt AC. Okay, Sankalp. 7 volt AC is applied. What is the overall displacement of that electron beam? That we have to calculate. So, but here, see that basic difference is here 10 volt DC is given and what they ask 7 volt AC. So, we have to convert this AC voltage into DC. Therefore, here 7 multiply. How you convert that? Multiplying by 1.414. And here, what is the total displacement? So, displacement is equal to 4 multiply 7 multiply 1.414 upon 10. This is our answer. Okay, this is our answer. In this way you calculate that displacement. But displacement, what they ask? Find the maximum displacement. Word carefully read the numerical. That maximum displacement, they ask for maximum displacement. Maximum displacement is VPP. Here you calculate VP only. So we have to multiply that displacement by 2. Then we get the maximum displacement. because you understand that CRO gives the maximum displacement like this. Your total displacement, this is your total displacement of electron beam, and that is termed as VPP. VPP means peak to peak voltage, right? Peak to peak voltage. And here displacement is just VP. Therefore here you have to multiply by 2. Okay? Now the third solved numerical, that read an unknown AC voltage is fed to the vertical input. Okay? Unknown AC voltage is fed to the vertical input of a CRO. Means some AC voltage. Now how you calculate AC voltage? Do you remember AC voltage is equal to VPP multiply volt per division reading? Okay. So volt per division knob is given 0.2 volt per division position. So vertical peak to peak distance. To calculate that VPP, number of vertical divisions multiply volt per division knob. So here number of vertical divisions are given 5 divisions. So how you calculate peak to peak voltage? VPP is equal to volt per division is 0.2 and number of divisions are 5. So 5 multiply 0.2, you get 1 volt. Okay. What is the second half of the numerical? In second half of the numerical, what they say that the vertical peak to peak distance, time based knob is on, means time per division reading is given. Time per division reading is given 50 microsecond per division. Now 50 microseconds you have to consider time per division. 50 multiply 10 raised to minus 6. Time per division reading is given equal to 50 microseconds per division. Therefore, you have to consider 50 multiply 10 raised to minus 6 seconds. Okay. And what they asked to calculate the horizontal spread of the waveform is 8 divisions. Number of horizontal divisions are given 8. Therefore, at that time, how you calculate time period? Time t is equal to number of horizontal divisions multiply the time per division reading, that is 10 raised to minus 6. Therefore, 400 into 10 raised to minus 6. Now, and how you calculate frequency is equal to 1 upon T. Okay. So, here frequency you calculate by using this formula. You may convert in milliseconds also. 10 raised to minus 6 microseconds by absorbing that minus 3 here. 400 in place of 400 you may write 0.4 into 10 raised to minus 3. That is your periodic time. Then F is equal to 1 upon 0.4 into 10 raised to minus 3. That 10 raised to minus 3 at the numerator it becomes plus 3. 1 upon 0.4 into 10 raised to plus 3. Therefore, 10 upon 4 into 10 raised to 3 means kilohertz, and 0.25 kilohertz is the frequency of that signal. This is your answer. All these are the solved numericals. Okay, in our next lecture, we try to simplify all 3 exercise numerical. You may try at home also, or these numericals are for homework. Okay, and next week we start that again chapter 2 of paper 2, because the remaining points, first we see that function generator in laboratory and digital multimeter you already know. So that 2 points we will cover in our classroom, or when we see in laboratory, that CRO and function generator. Okay. So any difficulty, if you are having any difficulty, then you may ask. Okay, we will stop our lecture here. Thank you.